Hi everyone, so we are back to using square roots, okay, but this time we are going to be solving quadratics. Rather than just solving the square root itself, we are going to solve the quadratics. You still need the information on how to simplify a radical because we will be using that throughout the lesson, okay? So the first thing I want you to do, you can go ahead and pause this video and do this warm-up just by simplifying each of the radicals, okay? So you're gonna go ahead and do that. Pause the video, and then when you're ready, press play, and we're gonna go over them, okay? Okay, now that we're back, we're gonna go ahead and simplify this radical. So we're just simplifying it. So remember how to simplify a radical. You're finding two numbers that multiply to get you 54, with one being a perfect square. So the two numbers I'm going to choose are 9 and 6. Gonna break it down. And my final answer is 3 square root of 6, okay? Same thing here, we're gonna break this radical down. Two numbers that I can use, okay? We are going to use, let's see. We're going to use 4 and 17. So 4 times 17 gives me 68, okay? I am keeping this 2 as I go along. So 2 square root of 4 times the square root of 17, because I'm breaking it down one step, okay? And then I'm going to break it down again. So the square root of 2 is 2. And remember, when you have multiplication outside of the radical, you can do so. So your final answer is -4 square root of 17, okay? So that is your final answer for that one. Now on this one, it's something that we learned a little bit last time in lesson, but the first thing we need to do is simplify that radical. Okay, and I am going to use 4 times 22. Okay, 4 being a perfect square, 22 can't reduce it down to anything with a perfect square, so we're going to keep it there. Okay, so break it down again. And my final answer is 2 square root of 22. And then what I need to do is I need to take that number and plug it back in for the 88. Okay, so I'm going to slide over a little bit. And I'm going to plug that back in. So now I have 2 plus 2 square root of 22 all over 4. Okay? And you can go ahead and keep your answer like that. You don't have to simplify any further. Okay? So those were your warm-ups, all right? Now we're going to go ahead and go down to some examples of actually simplifying or solving when we're taking the square root. Okay? Now, if you don't remember, the first thing, standard form, we know that, okay? And this is important. When we are looking to solve by square roots, you want to look when there's no bx term, okay? That's something important, all right? So you just want to see like an x squared and a number. You don't want to see anything like 10x, 7x, anything like that, okay? So now, if you remember, I'm going to write this over here. Give me 1 second. If you remember correctly, x squared, well, I don't want to say x squared, but I want to say when you take the square root of something, so I want to say that the square root and the exponent 2, or something squared, are opposite of each other. So square root is opposite of x squared. And I'm going to circle the little squared to make sure you understand that that's what it's the opposite of. So the square root and the x and the squared are the opposite. Now, when we do things that are the opposite, it cancels each other out. So say I had a -10, but I added 10 to that, it would give me 0. So in return, it cancels it out. Okay? So that's what we're going to be doing here. All right? So on this first example, when trying to solve, we need to find x by itself. X has to be just x. In this case, there's a little squared, okay? So we need that to go away. So what we're going to do in order to take that squared away, to cancel it out, is we are going to take the square root of each side. So if I take the square root of one side, I also have to take the square of the other. Now, I told you that the square root and an exponent squared, are the opposites of each other. So what that means is that the squared and the square root cancel each other out, and whatever is left in the middle drops out as the answer. So in this case, it's just x. Okay? Now, we all know that the square root of 9 is 3. But I also need you to pay attention here because the square root of 9 could also be negative 3, right? Because negative 3 times negative 3 is 9. The same thing as 3 times 3, okay? So here you have two answers, one being negative and one being positive, okay? Now, we can also write the answer as so. X equals plus or minus 3, okay? So that's what this symbol means. This symbol means plus or minus. So if you don't want to write it x equals 3, x equals negative 3, you can write it x equals plus or minus 3. Okay, so that's a different way to write it. On to the next one, okay? Now, we already have x squared by itself, so we just need to get x by itself. I can go ahead and take the square root of each side, okay? So now the square root and the little square cancels out, so x drops down, okay? And now I need to find two numbers that we can use to get 28, okay? One being a perfect square. So I'm going to use 4 and 7. All right, so then I'm going to break it down again. And my end answer is 2 square root of 4. Nope, square root of 7. Okay? Same thing. Remember here, you have to have a negative answer as well. So if I have a positive answer, I also have to have a negative answer, okay? Because the square root of 4 can be 2 or negative 2. Okay? On to the next one. So here, I do not have x squared by itself. So I have a negative 2 there. So in order to get x squared by itself, that's my first step, I need to divide by a negative 2 to each side. Okay? Now these negative 2's will cancel, and I'm left with x squared equals negative 16. Now, I cannot take the square root of a negative number. We're going to learn something a little bit later, but right now we are not taking the square root of a negative number. So if you have a negative, so what we would have done is then this is not applicable. Okay, so you're just going to put NA. We are not solving that because the under the square root is a negative number. Okay? All right, on to number 5. Okay, so same thing here. X squared is not on the left side by itself. So we need to do some things before we can go ahead and take the square root of each side. Okay, so my first thing I'm going to do is I'm going to add 180 to both sides. Okay, and I'm left with 5x squared equals 180. Now, x squared is still not by itself, right? There's a 5 in front. So what I need to do to get x squared by itself is divide. Okay, now my 5's will cancel out, and I'm left with x squared equals 36. Okay, so now I can go ahead and take the square root of each side because now I have x squared on its own. Okay, in order to get x by itself, I need to take the square root of both sides, so my squared and my square root cancel out, and like I said before, my x is left by itself. Okay, now the square root of 36 we know is 6, right? But you also have to remember that it could also be negative 6. So x equals 6 and x equals negative 6 is your answer. Okay, so now you're going to go ahead and do letters A and B. Okay, so pause this video and try them on your own. A is like example 3. And B is like example 4. Now, you're going to get a fraction in letter A. That is okay. All right? That's fine. That's okay. So go ahead and try that and then come back. Okay, so now that you are back, we are going to go ahead and solve A, okay? So first step is to get x squared by itself. Now, we have two numbers on the left side that aren't x squared. So the first thing I'm going to need to do is add 25 to both sides, okay? So this will cancel out. I'm left with 4x squared equals 25, okay? Now, my x squared is still not by itself. Okay, what I need to do to get x squared by itself is divide by 4. Okay, so now I'm left with x squared equals. 4 does not fit into 25 evenly. So what I want you to do is keep that there, okay? Do not reduce it. So you're going to have 25 over 4. Okay? Now we have x squared on the left side by itself, right? So now what we can do is take the square root of each side. So I'm taking the square root of this side, and when you take the square root of a fraction, you're taking it of the whole fraction. Okay, so what it really can look like is the square root of x squared equals the square root of 25 all over the square root of 4. Okay, now here is where my square root cancels out and my exponent cancels out. So I am left with x on this side. Now, the square root of 25 is 5, and the square root of 4 is 2. So here I have a fraction, okay? That would be my answer, but I can't forget that my other answer also has to be negative. So there's 2 answers here, okay? One being positive and one being negative. All right? Okay, now I'm on to letter B, okay? The first thing I need to do, I'm gonna rewrite it so I can see it better, okay? My x squared is not by itself, so what I need to go ahead and do is divide by 3 to get x on its own, okay? Now these 3's will cancel out, and I'm left with x squared equals 24 divided by 3 is 8, okay? So now I am at the point where I could take the square root of both sides. So I'm going to take the square root of this, and I'm going to take the square root of this, okay? Now, this will cancel, and I'm left with x equals the square root of 8. Now, this could be simplified, so you're going to keep simplifying it. So x equals 4 times 2, x equals the square root of 4 times the square root of 2, and x equals 2 square root of 2. So that's my end answer. But, one more time, the square root of 4 could be a positive 2, but it could also be a negative 2. Okay? So that's important. These would be your answer. Okay, so that's you going over them. Make any corrections if needed. Okay? All right, I'm going to head on to part of today's lesson. So we're not going to be doing the word problem. We're just going to, I'll be doing these examples with you, these 2 examples, and then you're going to go ahead and practice on your own. Okay? Now here, we have a little bit more of a challenge, right? There's more information on these problems, okay? So now, rather than just having an x squared, we have a full term squared. So here it's 2x minus 5. It's the full thing that's being squared, okay? So, the first thing that we're going to have to do is we want to get this whole term by itself, okay? So we need to get that -1 to the other side. So the first thing I'm going to do is I'm going to add 1 to each side, okay? So now I'll have that left side, 2x minus 5 squared equals 25, okay? So now I have this whole term, this whole squared term by itself, okay? That's what I want. So, in order to get this squared to go away, I need to do the same thing by taking the square root of each side. Now, that term is just a little bit bigger than x. So x is not just going to drop out by itself. So I'm going to show you here. So I take the square root of each side, okay? And now, what's going to happen is my square root will cancel, my squared would cancel, and I am going to take out this whole thing. That's going to drop out. So now I have 2x minus 5 equals, and the square root of 25 is 5, right? But remember, when we take the square root of 25, it will equal 5 and -5. So I'm going to set one answer up to 5 and one answer up to -5, okay? And now you're just at a 2-step equation, so you're going to go ahead and solve. So on this first one on the left, you're going to add 5 to both sides, okay? This will cancel, and I'm left with 2x equals 10. Then my last step to get 10 by itself is to divide by 2, okay? And 10 divided by 2 is 5. So in this case, x equals 5. Now I need to go solve the other side. So I've solved with the positive solution. Now I need to solve with the negative solution. Okay? So on this side, I'm going to add 5 to both sides. Okay? That's my first step to get x by itself. Those will cancel, and I'm left with 2x equals 0. Now, in order to get x by itself, I need to divide by 2. And any number that's divided by 0 is 0. Okay? So those are my 2 answers for this problem. All right? So we're going to do the other example, and then you guys are going to do them on your own. So on example 2, so this part over here. Now, this one has a little bit more extra of a step. Okay? There's one extra step in this part. But the same thing, we need to get this on the left side by itself. This is the only thing we want on the left side. Okay? So the first thing I need to do is I always do my subtraction addition first. So I'm going to add 9 to both sides. I'm doing the opposite operation. Okay? So now I'm left with negative 5, 4x plus 1 squared equals negative 39 plus 9 is negative 30. Okay? I still do not have this by itself. My squared term. I still do not have it by itself. So what I need to do is divide each side by a negative 5. Okay? These will cancel out. And now I finally have 4x plus 1 squared by itself. And negative 30 divided by negative 5 gives me a positive 6. Okay? So now that I have this term, right, this term on the left side by myself, I can go ahead and take the square root of each side. That's my next step. Okay? Once I take the square root of each side, the square root and the exponent will cancel out, and 4x plus 1 drops down. Now, the square root of 6 is as simplified as it can go, okay? So I'm going to put equals to the square root of 6. But I also can't forget to do the other one. So 4x plus 1 equals negative square root of 6. Okay? Now I'm going to zoom in a little bit more so I don't take up as much room, okay? Now here is the important thing. So when we're solving something with a radical on the other side, we have to realize that we cannot combine like terms with that. So my first step to finding x by itself would be to subtract 1. Now, square root of 6 and negative 1 are not like terms, so I cannot put them together. So what I'm going to be left with is 4x equals. Now here, it's important. You always want your square rooted term or your radical term to go last. So I'm going to put that negative 1, and then that square root of 6 is a square root of positive 6. Okay? So that's what I'm left with right now. And then my next step would be to divide by 4. Okay? So my 4's will cancel out here, and I'm left with x equals negative 1 plus the square root of 6 all over 4. And I want you to keep the answer this way. Okay? I want you to keep the answer that way. Then you're going to follow the same steps on the second side. So I'm going to subtract 1 from each side. Okay? Remember again, these are not like terms, so they cannot be combined. And like I reminded you in the first problem, the number always comes before the radical. So I have negative 1 minus the square root of 6. Okay? And then my next step is then just to divide. So I'm left with x equals negative 1 minus the square root of 6 all over 4. Now, notice that these answers are very similar. The only difference is one is a negative 6 and one's a positive 6. Okay? That's the only difference. So gotta look there, okay? Now, go ahead and practice those last two on your own, all right? Go ahead and pause this video when you're done, okay? Come back and watch. Okay, now that you're back, we're gonna go ahead, you can go ahead and check it as I solve these. Okay, so this problem is just like the problem above it, okay? So I am going to go ahead and follow the same exact steps that I just did on that problem above. So my first step to getting this by itself is to subtract 2 from both sides, okay? So now I have 9x minus 8 squared equals 400. And now that I have this by itself on my left side, I can go ahead and take the square root of each side, okay? So remember, when we take the square root of a term that's squared, the squared and the square root will cancel, and whatever is in the middle will just drop right out. So 9x minus 8 equals. Now, the square root of 400 is 20. So one side I'm going to have 20. But remember, it's also negative 20. So I need to make another equation that says 9x minus 8 equals negative 20. Okay? So now that I'm here, these are just two-step equations. Okay? So I'm going to add 8. We have 9x equals 28. To get x by itself, I need to divide. And this fraction is not reducible, so you could just keep it as x equals 28 over 9. Okay? I'm then going to do the same thing on the other side. 9x equals negative 12, divide by 9. Now, here, this can be reduced. Both of these terms are divisible by 3. So you're going to go ahead and reduce it, and it's going to say negative 4 over 3. Okay? If you left it like so, that's okay. I just wanted to show you that it is reducible. Okay? All right. Last problem is just like the one above here. Okay? So we're following the same steps. So in order to get this by itself, I'm going to add 1 first to both sides. So now I have 6 times 2x plus 4 squared equals 12. Okay? This is still not by itself. Okay? I need to go ahead and divide each side by 6. So now I have 2x plus 4 squared equals 12 divided by 6, which is 2. Okay? Now that I have this, bolding it, term by itself on the left side, I can go ahead and take the square root of each side in order to cancel out my squared, okay? So this will cancel out with this, and what drops down is 2x plus 4 equals. Now, the square root of 2 is as simplified as it can get, okay? So on one side, I'm going to have the square root of 2, but remember, I also have to set it up to be equal to a negative square root of 2 as well. Okay, so I've done that. I'm going to zoom in so I can write a little tinier and you guys can see. Okay, so same thing that we were doing on the problem above. The first step I need to take to get x by itself is to subtract 4 from each side. Okay, so I'm going to go ahead and subtract 4 from each side. Now, remember, these are not like terms, so they cannot be combined. Okay, and you always want to put the number first. So 2x equals negative 4 plus the square root of 2. Okay? Now, x still is not by itself. So what I'm going to do is I'm going to go ahead and subtract each side, divide each side by 2 to get x on its own. So I am left with x equals negative 4 plus the square root of 2 all over 2. This is how you're keeping your answer. Okay? You do not have to simplify it. That's how you're keeping your answer. All right? Okay, sounds good. So what we do to one side, we also have to do to the other. So I have to go ahead and solve this problem as well. So same first step. I'm going to subtract 4 from both sides. Okay? Remember, those are not like terms. So what I have is 2x equals, always put your number first. Negative 4 minus the square root of 2. Okay? And then in order to get 2 by itself, you're going to divide each side. Now these 2's will cancel out, and I'm left with x equals negative 4 minus the square root of 2 all over 2. And that is your answer. Okay? So we are not doing the word problem. So if you are feeling a little bit confused still on these, you should go back and rewatch the video or rewatch certain problems. If you have any questions, please email me. Okay? Next time, you will be doing a lot of examples on this. So today was just the lesson, okay? There's no homework. All right? All right, sounds good. Let me know if you have any questions.